All right, guys, this is Mr. Hausmeyer. There was a few of you that asked me to do some problems off of the paper that you had today, so I want to take a quick second and do that. It's about 10 minutes to 3 Friday afternoon, so school just ended a little while ago. But I want to take a quick second to go over some of the ones that I had not talked about in class. One of the ones that we had not done in class was number 5. So I'll start off with number 5 right here. Let's try to zoom this in for us. So on number 5, you're starting off, you have 181.35 grams of iron. So that's my given. What we said in class is that given is going to be written first. So I have 181.35 grams of Fe. One of the things also said to keep in mind is that as you're going through these, you want to make sure that you're keeping track of your units and what chemical it is that you're talking about. So what I'm looking for in the bottom is the number of moles. Now, it doesn't say moles of Fe here, but I'm still talking about Fe, so I'm going to write the Fe right there. And I'm setting this up as a proportion. The reason why I'm showing you this video is that if you look at YouTube videos, the YouTube videos are not going to show you this method that we're doing in class. Most of them are going to show you what's called dimensional analysis. So this one I think is going to be kind of beneficial for you over the weekend. Because this says grams of Fe, what our rules say in class is that when I do proportions, I want to have the same units looking directly across the line from each other. So if this is grams of Fe, this needs to be grams of Fe over here also. This says X moles of Fe, so this needs to say moles of Fe also. What I got y'all to write down in class earlier is 1 mole is equal to 2 major things we talked about. 1 mole is equal to 6.02 times 10 to the 23 atoms. It is also equal to what we call the molar mass. This is important because this is what I'm going to need for this question right here. I need to know what the molar mass for that chemical is. To find that molar mass, I have to look at the periodic table. So to find this, I need to look at the periodic table on my star charts. Unfortunately, I don't have a star chart to look at with you right now, but you can find, when you find your star chart, you're going to be able to find this number. When I find Fe, its atomic number is 26. It's in the 4th period, so the 4th row, and it's in family group number 8. The mass number for iron is 55.845 grams. So I'm going to write that for this problem, 55.845 grams of iron. This number is the molar mass. This molar mass, when I look back at it, the molar mass is equal to 1 mole. So where this says mole, this needs to say 1 mole. All right. So what I'm going to do at this point is I'm going to go through my cross multiplication and division and answer the question. I'm going to show you on the calculator how to put this in case you've forgotten. The very first thing I'm going to type in is a parenthesis because I want to tell my calculator exactly what I want it to do. So I'm going to say 181.35. I'm getting that from this number here. I'm going to cross multiply. In class, we skip this step because you're multiplying by 1, but for the video's sake, I'll go ahead and show you this. You're taking that number, and we close that parenthesis out, and I'm multiplying that times 1. I'm going to go ahead and hit enter. When I do that, you're going to see you have the same number. Any number times itself, or times 1, is going to be the same number as it was before. What I'm doing now is I'm going to take this number 181 and I'm going to now divide it by 55.845. When I do that, this number that's shown to me is telling me that X is equal to 3.24738, and the numbers continue. What I'm interested in is making sure that my answer is in the correct number of significant figures. When I look at this number that goes into getting the answer, this number has 5 significant digits. when I'm dividing that number, I look at this number over here. This one also has 5 significant digits. That means that I want my answer to have 5 significant digits. Usually we go with the lowest number of significant figures that went into getting the answer is going to be that number that our answer has. So if this one has, for instance, if this one had 3 significant figures and this one had 5, our answer would have 3. That's not the case here. Both of these numbers have 5 significant digits, so I'm going to make sure my answer has 5 significant digits. So I look at this, every non-zero number is significant. So I have 1, 2, 3, 4, 5, 6 significant digits that are shown. What I care about is the place value for the 5th one. So what is this 8 going to do for 3? It's going to bump it up. So what this then becomes, this is a correct answer, but this is not the correct answer that we need for chemistry. What we need for my class and for all of chemistry is for this number to be in correct significant figures. So I'm going to come down and write that this is 3.2474. Again, that 8 has bumped the 3 up to now this 4 that's here. The thing I have left to do on this question is to put my units and what chemical it was that I was talking about. So when I look back to the work I was shown, I can see that I'm looking for moles of Fe. So that's the unit is moles. The chemical is Fe, or iron, is the name of that. This is one we had not done in class, but we had done ones similar to this. One that's very similar to this that we had done was number 1. We did this one together with all class periods. I did number 1 with you. So number 5 is very similar to that. Also number 10 is very similar to that as well. Number 10 is very similar. You have grams to moles, just like this was grams to moles. They're very similar. Now, one that I got you to do in class was number 9. Depending on your class period, we either did number 4 together or we did number 9 together. What I want to do with you is look at number 8 again very quickly. So for number 8, I'm going to do the same thing I did a little while ago. I'm going to show out what is my given and what is my unknown, what I'm looking for. So I have 3.6 times 10 raised to the 24 power atoms of H, H being hydrogen gas. That's my given. I'm going to put that over my unknown. My unknown in this case is what I'm looking for. What I'm looking for now is the moles. So you can see the units that I'm looking for, the units I was given here are different than what I was given up here. So my units are all going to be different for this particular question. You have to look to what you're given to see how your problem is going to be arranged. So what I want to do at this point is lay out the units directly across from each other have got to be the same. So if this is atoms of hydrogen, I want to make sure this says atoms of hydrogen also. If this says moles, I want to make sure this says moles also. And I'm going to go ahead and put the H for hydrogen. What I want to do at this point is I want to make sure that I have the correct numbers in these two spaces right here. This is atoms of hydrogen. So when I go back up to the top of my paper that we filled in earlier, 1 mole is equal to this many atoms. 1 mole also equals this molar mass. What I'm interested in for this question is that number of atoms right there and the number of moles. So here's what that's going to look like. Every time I see atoms, that number 6.02 times 10 to the 23 is always attached to the word atoms. When I see this word moles, moles is always going to be across from the number 1. Because what I'm doing is I'm comparing my numbers together. The reason why I'm doing that is that I don't know what the relationship is between these numbers, but when I put this down here for that 1 mole, I know what the relationship is between these numbers is absolutely true, never, ever, ever going to change. This is always the same. So the same thing as what I did up here, where I cross multiplied and divided, I'm going to do the same thing here. I'll show you that on the calculator as well. I'm going to type in an open parenthesis, because again, the calculator is not as smart as you. You got to tell it exactly what you want it to do. I've opened a parenthesis. I'm going to type in 3.6. And then to get this times 10 to the 24, I'm going to hit my second button. And there's a comma key right above the 7 that has that little E right there. I'm going to punch that one time. And then I want to show in my exponent. That E basically stands for exponent. My exponent here is 24. So I'm going to type in 24, close that parentheses out. I'm still cross multiplying and dividing. I'm multiplying by 1. Now, this step is important, but it's not necessarily important to show right now because I know that if I have a number times 1, it's going to be the same number as what I started with. So I'm going to skip this step for right now. What I want to do is I want to now divide by this number right here. So I'm just going to show that here. I'm going to hit my division button. I'm going to open up a set of parentheses and type in 6.02. Hit my black comma key. Oops, pardon me. Made a mistake there. Hit my E, type in my 23 because that's the exponent that's here. And then I'm going to hit enter. This number that I'm given, after typing in my 3.6 times 10 to the 24 and dividing that by 6.02 times 10 to the 23, this is the number that I get for my answer. So x is going to be equal to 5.98, and it shows 0.0664445. All of these numbers are not significant. They're not important for me to show in my answer. What I want to look at again is having the correct number of significant figures. This number that I started with has 2 significant figures. I know that because both of those numbers are non-zero digits. Non-zero digit is just a fancy way to say any number that's not a 0. So this has 2 significant figures. The number I divided by has 3. I only consider the what we call the coefficient on scientific notation. So I only consider the first numbers here and the first numbers here. My answer needs to have only 2 significant figures. So when I go to rewrite this to have the proper answer that we want, I need to round this number. The 9 is in the place of the second significant digit. So this 8 is going to bump the 9 up, or what we say is round the number up to the next digit. So the only place 9 would have to go would be to a 10, but I can't write 0.10. What I'm going to do is now this 9 is going to change the 5 also. So what I'm going to write now is going to be 6.0. This number has 2 significant figures. This is going to be 6.0. My unit is moles, and my chemical is going to be my hydrogen that I had up here. I forgot to write the symbol. Go ahead and write my little H in there. This is going to be moles of hydrogen. This number has the correct number of significant figures. I'm going to box this answer up and move on to the next question. Now, I didn't box this answer before, and I meant to do that, so I'm going to go ahead and do that now. This was our answer on number 5. This is number 5. The question I just did is number 8. Number 8 is the one that I just did here on your paper. I have to leave because I need to go pick up my children, but I wanted to do a couple of these that I had not done with you yet, but I want to leave you with this. The most important thing to remember when you're setting up these is to make sure that your units are matching directly across. So, for example, in this one again, I had grams to grams. I had moles to moles. On this example here, I had atoms to atoms. I had moles to moles. That is the most important thing to remember. The other important thing to remember is all of your conversion factors that are up here, they are all equal to each other. So what I told you in class is 1 mole is equal to what we call Avogadro's number of atoms, which is this number here. 1 mole equals this many atoms. What this also means is that that many atoms are equal to 1 mole. What that also means is that 1 mole is equal to what we call a molar mass. The molar mass is being the decimal numbers that are below the chemical symbols on your periodic table. What this also means is that these two numbers are equal to each other. If I have this many atoms of any element, it does not matter which one. If I have this many atoms of an element, I have a particular molar mass. It is different for every single element that's out there. Everything that's here, all those three things, they are all equal to each other. And I can switch those things around, move those things around in any way that's needed to get to the answer to the problem. Now, there are 10 questions on here. What we did in class is we had done number 1, we did number 2. Some classes did number 4 or 9, but we all did one or the other. So 4 and 9, those are the ones that we did together. And many of you had gone through, because we had some time, many of you had gone through and started working on some of the other problems that are here. Okay? Work on this over the weekend. Bring this paper back, and we will go over this. I'll finish out making my key for this. We'll go over this. I'll answer any questions. And then I have a different activity that we're going to work on that's going to give us even more practice. This is going to take a lot of practice to get this down. Okay? If you are not understanding this right away, that is fine. There are a lot, it's a difficult topic. It's a difficult topic. It's tough, but we got to be tougher. Okay? You're highly, highly, highly intelligent people. You can do this. Okay? Do not tell yourself I can't, and do not give up on yourself. Okay? We're going to get through this. This too shall pass. All right? So if you have any questions, you can email me. My email address is key.hassselmeier, the @ symbol, kind of like on Twitter, CF as in Frank, ISD.net. That's my email address. And there it is right there. My apologies. You can forward through or rewind this video. You can do whatever it is that you need to do to help you to understand how these questions are done. I hope you guys have a wonderful day. I hope you have a great weekend. Stay dry out there. We're supposed to get a lot of rain. Have a great day. I'll see you Monday.